welcome to the session 2.3 of your chapter Optics. So in this chapter, in this session, we are going to discuss the 2.3 topic, which says refraction of composite light and hyphen dispersion of light. So actually, we are going to start with this topic in this session, but actually in last session, what we discussed is very simple: refraction of light. So what is refraction? It is the bending of light when light enters from one media to another media, and this is a phenomenon. So refraction has two laws similar to reflection. So the first law states that incident ray, reflected ray of light, and the normal to the refracting surface all lie in the same plane. And then second law is very simple. We don't need to remember this thing. We just remember sin I by sin r is equal to mu 2 by mu 1, or else we can remember as mu 1 into sin I is equal to mu 2 into sin r. So mu 1 is refractive index of first medium and the mu 2 is refractive index of second medium. I is incident angle and r is refracting angle. So that's all about second law of refraction, and we just saw the explanation regarding these laws and some other features of the law. And that's all refraction of light. Coming to 2.3, and in a short manner I can see that today's class, actually we know light is a form of energy, and it is also represented in form of waves. So actually when we are talking about waves have lambda, what is that? Wavelength, amplitude, pitch, time taken, crust, trough, everything. So if wave is having these fundamental quantities, then it is sure that light will also have these fundamental quantities. I can't say quantity, we can take it as fundamental measures. That's a good term. Okay, so we are starting with the paragraph. We know that sun is the fundamental and natural source of light. Yeah, we all know that sun is the fundamental source of light. It is giving heat, light, and everything. Life on earth pertains due to suns. If no sun, no life on earth. Then if a source of light produces a light of single color, it is known as monochromatic source. So if you see red color light, red color bulb which is emitting red color light, then that source is called as monochromatic source, because it's emitting just red light alone. It's not going to mix a red blue color and it's going to emit some different color. But if you take a CFL bulb which is fixed in your room or in your hall, in your home, or a tube light, anything, any source which is going to emit white light is not monochromatic source, because white light is a mixture of 7 colors which we call as Vibgyor: violet, indigo, blue, yellow, green, orange and red. If these colors combine, then we get white light. But you can ask me a question, that if you mix these Vibgyor colors by using paint, if you're gonna mix Vibgyor paint in a single tray, you won't get white, because in this chapter, white light means it's light, it's not color. Light is different from colors. See, if you're gonna take a red crayon and scribble it in the wall, it pretends to be red, but actually if you turn off your lights in your room or make the room darker, then if you try to see the color which you painted in the wall, you won't be noticing that red color, because that crayon is not gonna create the light which is mentioned as a red. But if you actually use a laser light in a dark room, it actually gives red light, then that's the source of light actually. So this is what I wanna say: the color and light are different quantities. We can just interpret them. We can't say that these two are same. We can interpret, that's all. So that's what I want to say. CFL bulb, that white light is actually a mixture of 7 colors, or 7 color light. That is a better term. and that's why we are not going to call CFL lights or white lights as monochromatic. Coming back to the text, on the other hand, a composite source of light produces a white light which contains light of different colors. And this thing I explained now. See, if you think that my words are a bit faster and you can't understand it better, then just turn on your captions, which you will be getting in this three dots. Here, three dots will be created now while you are watching YouTube. So if you click this and if you turn on the captions here, Google will, YouTube company will just provide you captions. Captions means just subtitles which will be running here. It will just translate my voice into text. It will be easier to understand. Okay, just turn on it if you feel uncomfortable with my voice. Then, sunlight is a composite light which consists of light of various colors or wavelengths. Uh, if you just take a look at the sun or the sun's light in evening time, it will appear red, and or in early morning time it will appear red or yellow color. But if it becomes afternoon, it eventually gets lighter and lighter. That means it's approaching white color, and that's mean white color mean band of 7 colors. So exactly what this means is that sun is going to emit various types of light or color, but due to the mixing of those colors, white light is created. Okay, you're getting something. White light is the band of 7 colors. So if sun is going to emit all the colors, then all colors will be mixing with each other, and it's going to create white light. So sunlight is which consists of light of various colors or wavelengths. And then another example for a composite source is a mercury vapor lamp. Mercury vapor lamp. I too haven't heard about this lamp, but what you can think of is that a Betramos light. A Betramos light which is going to emit some kind of whitish yellow color. So that is also mixing of some colors, but red color is added some in extra quantity. That's why it's going to emit a light yellow color. That Betramos light may be mercury vapor lamp, I guess. I don't know what is that exactly. In this paragraph, two words are very important. Monochromatic source. Monochromatic source is a single color of light source, and then composite source is white light source. Eventually we can say it as white light source. For example, sun or mercury vapor lamp. You can write anything. Then what do you observe when where white light is refracted through a glass prism? So what is a glass prism actually? You might have seen it in your 9th class, I guess. Your teacher might have shown it. And appropriately or approximately I can say that this is a glass prism, and it is an extended pyramid actually. So this full prism is made up of glass. So if you going to hit a white light here, it will just refract till the end, and again it will also refract back into a band of 7 colors. So if you hit a white light in this direction, all the 7 colors, that is violet to red, is going to come in the other side. So this happens due to refraction or dispersion of light, we can say it as in common. So that's what they are asking. What do you observe when a white light is refracted through a glass prism? You will see all the 7 colors. When a beam of white light or composite light is refracted through any transparent media such as glass or water, it is split into its component colors. This phenomenon is called as dispersion of light. Well, they can ask state dispersion of light or say about dispersion of light in your question paper, so you need to write this definition. And for example nothing is there. Okay, for example, take white light which is hit in a prism. That's it. So they said about dispersion of light. Dispersion means separation, dividing, or we can say anything else. Separation of light. See, when you are going to hit a white light through a prism, it is going to separate into 7 colors. And why this is happening is due to differences in the speed of light. I mean, oh, okay, we will be discussing it later. Fine, and that's called as dispersion of light. Very simple. You need to remember this. Then the band of colors is termed as spectrum. This is a good term. Actually, when I was studying in 10th standard, my physics sir used to always ask, "What is spectrum? What is spectrum? What is spectrum?" in our daily test. That's a frustrating thing, but actually, he did good things because he made himself bad, and among us, he made himself very bad that we think he is so rude because he is giving test all the time. We think he is very rude, but when I went to write the exam, the questions which he was asking continuously came there in the paper. So I thought, no, he was not rude. He just making us to understand that it is important. See, if teachers are doing something, then there will be some reasons. There is some reason. There is a good reason behind. So you must not think that your teacher is very bad. No, he is going to teach you something. Teaching is his job. Don't think he is rude. He is very good. Okay, coming back to this, the band of 7 colors. Band of colors is termed as spectrum. There is nothing to it. Band means a bunch. Then the spectrum consists of the following colors: violet, indigo, blue, green, yellow, orange, and red. It is shortly called as Vibgyor. The first letters. That's it. Why do we get that spectrum when white light is refracted by transparent medium? You must ask me, right? Sir, why is white light is going to split into 7 colors when you hit it in a prism? You must ask me. Questioning is the job of a student. Answering is the job of a teacher. So you must question, you must think, you must comment it. And this is because different colored lights are bent through different angles. That is, the angle of refraction is different for different colors. See, take 2 examples. And this is normal actually. The upper portion is air and the lower portion is water. The same for here. Upper is air, lower is water. We are going to incident red light here, and here it is a violet light. Both have incident angle I and I. So if this is 30°, then this will be also 30°. And what you might be saying is that this is the path which the light must travel if there is no interface. Okay, what I said, this is red color light and this is violet color light. This is because different color lights are bent through different angles. That is, the angle of refraction is different for different colors. If this is red and it is going to bend more, it's just for an example I am saying, and this is violet, so it is going to bend a lesser than red. So if this may be 10° and this may be 20°, there is difference in what is this angle called as? I always forget some things. Angle of refraction. Yeah, angle of refraction. There is difference between angle of refraction. So if you're gonna incident a white light here, white light, it will be, there are 7 colors actually. Say if you take a beam of white light, it will be having 7 different beams. That is, one is violet, one is blue, one is green, yellow, red. All 7 beams will consider or coincide it to form a white beam. So the white beam is going to incident in this interface, and due to difference in this refracting angle, each and every color is gonna refract in different ways. In different angles. So this creates the band, the spectrum, and dispersion of light occurs due to the variance in angle of refraction. So that's the reason dispersion of white light occurs. This single line explains all the things about dispersion of white light. Then angle of refraction is the smallest for red. See, I actually explained here. Red will be having 10° and violet will be having, what is that, 20°, I guess, 20°. Angle of refraction is the smallest for red and the highest for violet. Red will be having lesser angle of refraction than violet. Yeah, this is good now. So if you gonna turn in some other way and your friend is gonna turn in some other way, but eventually in beginning you both started in the same path, but due to some variations or due to some different speed, due to some disturbance, you are going to go in right side and your friend is going to go in left side. That's happening here. Red light is going to deviate less, deviate more. Yeah, it is because it's going to get very less refracting angle, right? So it's going to deviate more red light, and violet light is going to deviate less because violet light is having greater speed, more speed than red light. See, I need to explain one thing for you. So what is red light and violet light actually? So, you know what is light? And light is a form of energy and it is traveling in waves. So waves have frequency and wavelength. So what scientists thought is that they took one color. They don't know what is that color. See, if you are going to take orange color, they eventually not said that this is violet color, or they might have said I don't know. See, they named this as violet color, but this violet color must have some properties, right? Yeah, we are just seeing it and we are saying that this is violet color, but for some further studies, for some research works, books, they need some extra clarifications. So they said that any light with a frequency something and with lambda, wavelength with some value, is called as orange, orange colored light. And the red color light was given some frequency and some other lambda, wavelength. And similarly for violet light, and all colors were given independent frequency values and independent wavelength values. uh, so if you need to take something, I don't know whether violet light or red light will be having 400 nanometer of wavelength. Nanometer refers to 10 power minus 9 meter. So this much the wavelength must be there to get either violet light or red light. I don't know, I'm not confirmed with it which color will be coming for that. So if this is the wavelength, then the light is set as red or violet. And similarly for other colors, they said, they marked it as this is your wavelength, this is your frequency. If this is the frequency and this is the wavelength, then you are named as orange, then you are named as green. Similarly it was done. So this is how colors were given, and colors were given their properties. Where I left? Okay, I gone somewhere. Angle of is the smallest for red and highest for violet. Okay, from Snell's law. What is Snell's law actually? We read it here, na? I'm sorry for that. We read it here. This is called as Snell's law. Second law of refraction is called as Snell's law. This formula is very important. You must learn it by your whole-hearted. And keep on saying that your 10th and 9th syllabus or your basics for 11th and 12th. If you're going to study 10th and 9th better with a kind heart, you will be doing your best in your 11th and 12th. You won't be having any difficulties. That's why we are saying read physics, read chemistry. It will be helping you in 11th and 12th in a great manner. You won't think that, oh, he said that to learn 10th maths, 10th science and maths, but I didn't read it. Now 11th and 12th are very tough for me. You will be thinking once you enter 11th and 12th, everything you are learning in 10th will be the best basics concepts which you will be doing it in 11th and 12th. Okay, I'm going on. From Snell's law, we know that the angle of refraction is determined in terms of the refractive index of the medium. Once refractive index of the medium, that is mu or mu 1 mu 2, which we are representing in Snell's law. Actually we saw before, now that's mu 1 and mu 2, which is refractive index. That the angle of refraction is determined in the terms of refractive index. Yeah, because Sin I by sin R is equal to mu 2 by mu 1. That means sin I, incident angle, and R is refracting angle. So refracting angle is dependent on refractive index of the mediums. You're getting it now? It will be clear. Wait. Hence, the refractive index of the medium is different for different color of lights. They are saying another point. Refractive index. Wait a minute. Yeah, I'm clear. Sin R into mu 2 is equal to some value, right? Take it as x. So if I am going to take mu 2 to this side, it will become as sin R is equal to x by mu 2, and that means sin R is inversely proportional to mu 2. If refracting angle is going to increase, then mu 2 is going to decrease. That means refractive index will decrease, which says that, see, we just read before now here somewhere, yeah, different lights, different colored lights will have different refracting angle. So if there is different refracting angles, then we can expect that for each and every color there is different refractive index for different media. See, if water's refractive index be 1.2, it might be 1.2 just for red color, but it might be 1.224 for violet color, 1.225 for green color. Depending upon the color, the refractive index of the medium changes. That's what they are saying here. Hence, the refractive index of the medium is different for different colored lights. This indicates that the refractive index of a medium is dependent on the wavelength of light. Light is a form of energy and light is a wave. So wave has wavelength, lambda. So light is also having wavelength. Since different colors of light have different wavelength, so for different wavelengths, different refractive indexes are there for same medium. See, I'm just confusing, I guess. If you take water and if you are going to hit a red light, that red light will be having a wavelength, and for that wavelength the water will be having some different refractive index. And instead of red, if you're going to hit it with a violet light, then violet light will be having some different wavelength apart from red light. So for that wavelength, the water will be giving some different refractive index. There is differences in refractive index due to different wavelengths. That's the last line explaining here. Very simple. If you just repeat this line which I spoke right now, you will be understanding it better. Hear it very slowly. Keep it in 0.25 into x something speed. Just lower the speed actually. You can get it better. I explained it. I'm damn sure I explained it. And that's all. The session 2.3. It's over now. Thank you. If you have any doubts, comment it and like it, share it, and do subscribe my YouTube channel. Bye bye.